Let's go ahead and look at homework exercise number 14 from section 10.6. The road is inclined at an angle of 7 degrees, so there's our 7-degree angle, angle A. After driving 52 feet along this road, so he has driven 5,200 feet right there. This road, find the driver's increase in altitude, so he's going up a hill. Altitude would be the vertical change, would be the side BC labeled A, right? So in terms of angle A, the vertical change we need in altitude is opposite, right? Here's the right angle. We'll assume altitude forms a right angle with the land, the height. So it's the side opposite, and then here's the right angle. So actually the 5,200 feet is the hypotenuse, right? It's the hypotenuse because it's opposite angle C, which is the right angle. So the trig function that involves opposite and hypotenuse is the sine, right? So the sine of angle A, which is 7 degrees, right, is equal to the side opposite. We need to find with the altitude or vertical change over the hypotenuse, which is 5,200. So multiply both sides by 5,200, and we get A equals 5,200 times the sine of 7 degrees, okay? And of course, we can use our calculator, put that in to get our answer. Again, remember, you've got to make sure you have to hit mode, and you have to make sure go down your third line. If it's in radians, you need to highlight in degree, because we want the answer in degrees, and then you have to hit enter to save it, and then you hit second mode again to quit, and now we can go ahead and put it in, which was what, 5,200 times, you can just put in sine and automatically multiply of the angle, which angle A is 7 degrees. So the vertical change to the nearest whole number, 633.7.7, means we would add 1 to the units, the ones digit, so we would end up with 633 plus 1, which of course is 634, rounded to the nearest whole number. All right, very good. Let's look at number 15. From the point on level ground, 52,800 feet from the base of a television transmitting tower. So we'll say here's our tower. From a point on level ground, here's the ground, 52,800 feet. The angle of elevation to the top of the tower is 21.5. So elevation is right here, 21.5 degrees. It's with respect to the ground, looking up at the top of the tower. Approximate the height of the tower, so we'll call that H for height, okay? So again, the tower we'll assume is put in at a right angle to the ground, so there's our right angle. So what we have here is we need to find this side, which is with respect to the 21.5 angle. This is one of the legs, this is the side opposite, right? And then this also forms a right angle, so this side is adjacent, right? They're the two legs. All right, and so now the trig function that involves the opposite and the adjacent is the tangent, right? So the tangent of angle A, 21.5, or that 21, is the side opposite. We're trying to find H over the side adjacent, 5,280 feet. So multiply both sides by 5,280. And then these will cancel, so you'll get H is equal to 5,280 times the tangent of 21.5 degrees. And that will be this side H, which corresponds to the height of the tower. Okay, so we'll put that into our calculator. That's 5,280 times the tangent of 21.5 degrees. All right, 5,280 times the tangent of 21.5, and we get 2,079.8, again rounded to the nearest whole number. There's a 0.8 in the tens, so we'd round to 2079 up to 2080. We'd add 1, so of course that would make the 79 2080. Very good. Let's look at number 16. A statue in a harbor is approximately 255 feet tall. Okay, so our statue here, well, maybe I shouldn't. I'm not an artist, as you can tell. Let's pretend this is the statue. Okay, is approximately 255 feet tall. If the angle of elevation of a ship to the top of the statue, so here's the ship, okay, to the top of the statue is 18.6 degrees. How far is the ship from the statue's base, which is along the water here, right? So this side, which I don't know, we can call D for distance, okay? So there it is. It's how far from the ship from the statue's base along the water here, right? So it would be this side. Now, here's our right angle with the statue. So with respect to the 18.6, this 255 is a leg, right? Forms the right angle. It's opposite. So this is opposite, and this is the other leg, which is next to it, which is adjacent. So the trig function that involves the adjacent and opposite sides is the tangent. So the tangent of the angle, which is 18.6 degrees, is the side opposite, 255, divided by the adjacent, which is D. So again, we're missing the side in the denominator. So we've got the extra algebra step. Multiply both sides by D. D's cancel. And then get D times the tangent of 18.6 is equal to 255. So then we would divide by the tangent of 18.6 degrees. Okay. And that will cancel, and D will equal that. So again, be careful. It's 255 in the numerator divided by the tangent of 18.6 degrees. Okay, so you got to get the order correct. All right, so we'll go ahead and put that into our calculator. 255 divided by the tangent of the angle, which was given to be 18.6. And the statue is 757.7 feet, rounded in the nearest whole number. There's a 0.7 in the tenths, so we add 1, and it would make it 758. Okay, we're going to go ahead and stop this session at problem number 16. This is your math teacher, Dr. Swears. I hope you found this video helpful. If you still need more help, please send me an email using the inbox in the Canvas course through the FGCU portal. Again, thank you this is your math teacher, Dr. Swears. Thank you for listening to this video.